Okay. See, this aspect, we're not applying it now. We're going to apply it later in the next section, which is area under the curve. So when I get to area under the curve, I'm going to say it's an integral of something from somewhere to somewhere, and you might be wondering what is that. So we're going to talk about definite integrals first. All the integration we've been doing so far, they are indefinite integrals. Indefinite in the sense that we're not being specific. We just integrate with a function. Okay? But definite integral gives us a value. Okay? And this is how it is done. So, what does definite integral really mean? How is it done? Let me put it that way. If the integral of this function with respect to x, the indefinite integral now, gives a function, maybe capital F of x plus c. Okay? By the definite integral from a to b of this function, so you will integrate normally, you get this. There will be no need for plus c. You will understand why very soon. You put your limits when x is equal to a and b, and what you do with it is to substitute the upper limit and substitute the lower limit and subtract. So this is going to be f of b minus capital F of a. If there was plus c, it will have been f of b plus c minus f of a plus c will have cancelled plus c. So in definite integral, we do not consider c at all. Okay? Now there are some properties of this, but before we get to that, let us try to apply this in one or two problems and see. Question 1. Let's consider the integral of x squared dx, maybe between 1 and 3. First, integrate, you get x cubed divided by 3. Right? Then we're going to apply the limits. So when x is equal to 3, 3 cubed over 3. When x is equal to 1, 1 cubed over 3. And your result will be 9. Am I right? So that's 27. Or 27 over 3 minus 1 over 3, which is simply 26 over 3. This is the value of that definite integral. So that's why I said it's a short topic. We just need to know all the techniques we have been using so far. I can have maybe from 0 to pi over 2 of sine x dx. Okay? Again, what is the integral of sine x? Are you sure? Yes, you are right. The fact that I said no, you should be sure of what you are saying. I just said, just to confuse you. And I won. Derivative of sine is cos. Integral of sine is minus cos. So this is minus cos x within the limits 0, pi over 2. So again, we substitute. For pi over 2, you get minus cos pi over 2. The minus, can you see? I put a bracket. Minus cos what? 0. Now what is cos 90? That's 1. So this is minus 1 minus, what is cos 0? Cos 90 is 0, not 1. This is the 1. Always remember your sine function and cos function. Can you see? Cos 0 is 1. But cos 90 is 0. Unlike sine, the 1 is at 90. Okay? And the 0 is at 0. So basically, anyway, calculator is allowed. You can use it. This is equal to 1. What this means in the next section is that if you draw a curve, x squared, the curve x squared will look like this. right? And it turns at 0, like this, right? If you find the area between 1 and 3 under this curve, this shaded part, the value of the area is 26/3. That's where we are going next section. Okay? Similarly, if you plot the sine curve, which is something like this, between 0 and pi/2, no, that's pi. Pi/2 is here. The area under this curve is 1. Okay? So that's the technique. That's where we are going next. So I'm going to write the next two questions. I want you to attempt it before we start discussing something. Oh no, what we want to discuss, I want you to discover it yourself. Okay? So by solving some problems. So let's start. Try that. Let's see what happens if we change the interval. They are all related, so the integral is the same. Only the substitution will differ somehow. Quickly, please. Everything okay? We also do a section where you use calculator to solve integral problems. You should be able to maybe combine all that tomorrow. You can see there's nothing new other than substitution, right? Every other thing is exactly the same. So There's no need to waste too much time on them. And then the 45 questions, among the 45 questions that I printed for you, number 31 to 45 are past questions. So there are 15 past questions. Others are mostly from your textbook or from other sources. All right? Change position. Okay. We finish at 1 today, right? Nice. By now it should be number 5 at least. Yes? The functions are similar, so once you integrate once, the rest is just to copy and paste your integral, right? And just change your substitution. So. Battery, turning it off. I don't know what to say to you anymore, Clarissa. You want to migrate also? Oh, are you saying others cannot see? Are you saying they have eye problem? Krista, did you see what she just did to you? You and Lillian? It's like, oh, I can't see. You only those that cannot see move. That's what she implied. What number are you now? 10. Okay. Who is still in number 8? Raise your hand. Number 8 or below. Okay. Fast. Are they my complete? So does anyone have the textbook, the green one? No. Oh, again.
莉莉啊，第10题是obtuse还是什么？对啊。
2 more minutes, please. Then we discuss the properties.
不是2，为什么？我为什么？我在那个第4题。为什么？你还没有加对吧？没4跟2。你这个是附是外面的，不是你里面附的，不是用 over 跟 how 上。一样，跟那个然后不是 s 到4那边吗？对，这个。我完蛋了。所以咪就係咯，咁你所以就冇得咁你什麼意思？你附近好似同你頭先嗰個教會差唔多。
I need everyone to complete up to 11, please. Where's the camera lady? Oh, okay. Oh, well, I didn't say that.
那這個是什麼？
Who's this? Is that Nakita?
哦，
Is this it?
對對對。
Everything all right?
Yeah.
Some people can't see. Except food, they can see food. Paper 3 format question, I have about 9. I was able to source for like 9 of them. So I want us to start printing them from, say, February. What number is Nakita now? 10. Karen?
4. I did it all wrong.
Oh, okay. So in 2 minutes, I'll stop you. Then are you done? Did you notice something? If you're through already, try to make some connections between numbers that look alike. Then we can make a generalization in the next 2 minutes. So that is what we will call the properties of definite integrals. Did you notice something already? That's all about properties once established. Okay. Okay, everybody, let's stop. Let's stop, please. So I'm not going to do everything. I'm just going to, based on what has been done, others can verify it. So this, you must have converted this first, this way. So basically, of course, this is, if you want to read it, integral from 4 to 9 of square root of x with respect to x. That's how we read it, okay? Anyways, so this will be x 3 over 2, 3 over 2. Is that okay? Mm-hmm. I use vertical line. Some in your textbook might be this. And the square bracket is okay. I'm used to this one. So this is 4, this is 9. Okay? Such that this is, then the 2 goes up. Okay? So you have 2. So I'm writing it in form of root because I'm having numbers to be substituted. Okay? So that will be the square root of x to the power 3. Of course, you don't have to write it in this form. I write it in this form so it's easy for me to do when I substitute numbers. So, when I substitute the upper limit, okay, the upper bound of the integral, I can say the upper limit. So, that will be the 2 square root of 9 cubed divided by 3, 2 square root of 4 raised to the power 3 divided by 3. So the square root of 9 is 3, raised to the power 3 is 27, times 2 is what? 54. Yes? Mm-hmm. And this gives me 8, 16. So what is 54 minus 16? 38. Mm-hmm. Right?
Yes.
38 over 3. So you will notice that similarly, this is going to be minus 38 over 3. Because the minus comes out of the integral. So the minus is going to be out of here. So the minus is waiting outside a bigger bracket, and then the minus affects this. So when you flip it, the only difference is between this and this is that 16 over 3 comes first, followed by this one, instead of this way. So at the end, this will give you negative 38 over 3. Am I right? Mm-hmm. So you can see clearly that this and this are the same. So that's one property of definite integral. The property is that, number 1, the integral of f of x dx from x from a to b is the negation of b to a of the same function. So once you flip the intervals, okay, with which you are finding the area, you're going to end up getting a negative value. Of course, when we are finding the area, we always use absolute value, depending on where I'll tell you what to do. Sometimes we use absolute value if you're sure that it's below, to avoid negativity, because you can't say area is minus 2. That minus is only telling you it's below the x-axis. All right? So this will be useful in some problems where you need to just combine some things, and you will see that very soon. So that's one property. Once this interval flipped, you will have opposite of when it was not flipped. Similarly, you should have done this, and you should have gotten what? X cubed over 3, right? If you substitute 1, you get 1 cubed over 3, then 0 cubed over 3, so you should get 1 over 3. Similarly, you will get the x cubed over 3 also. 1 to 2, right? So this is 2 cubed over 3 minus 1 cubed over 3. So this is 8 over 3 minus 1 over 3, which is 7 over 3, right? Well, let's look at this one. X cubed over 3, 0, 2. I hope you can see. So that gives you 2 cubed over 3 minus 0 cubed over 3, which is 8 over 3. So you can see clearly that this and this added together gives this. The implication of this is that from 0 to this, and from this to, if the end point of this is the beginning of the next one, is as good as starting with from here and ending at this one. And it makes sense. I just told you that the next section is area, right? So if you have your curve, let's even talk about just a line. Okay? Area under this curve from here to here and from here to here, isn't it the same as area from here to here? So if you say area from A to B and area from B to C, it's as good as saying area from A to C. So the second property that you have seen here is that the integral of A to B of f of x dx plus the integral of B to C of f of x dx will give you what? The integral of what? A to C of f of x dx. And the next property can be seen here. After you compute this, you realize it's actually 3 times this one. Right? You realize, did I get this right?
Yeah.
Okay, you realize 3 times this one. So basically the integral of a constant, just like other integration that you have done, the constant can be removed while the integration is completed, which is what we actually considered here. Because you have to take the constant out, complete the integration, and put it back. And last but not the least, the fourth property will be observed here. This is still this function. I'm going to copy that function. The function gives 2 square root of x to the power 3, yes?
Yeah.
Everything divided by 3. Like that. So if you substitute 1, you just get 2, 1, square root of 1, that, then 0. Anyway, we know that it's going to be 0 anyway. Let's just put it there. So you get 2 over 3, yes? Now, this plus this is going to be this. You did get 3 when you did this one. Or 1, sorry. You get 1. So if you do the function, you get x squared, x cubed over 3. And this would have been 2 square root of x all squared, or all cubed over 3, like that. The integral of this and the integral of this. Everything within 0 to 1 is as good as just putting it 1, right? By the time you complete this calculation, you should be able to get what? 1, eventually. That 1 is the combination of this and this. So what it's saying is that, just like the normal indefinite integral, where you do your integration term by term, the definite integral also works that way. So the last rule is that the integral of a to b of f of x plus g of x or minus g of x with respect to x, it's what? The definite integral from a to b of f with respect to x plus or minus the definite integral from the same limit within the same interval. Let's put it that way, not limit. Of g of x dx. So these are the properties of integral, of definite integral. Okay? Now I want you to use this property. Look at your worksheet. Look at your worksheet. I want you to attempt question 5. 5ABC. It says, write as single integral. Don't evaluate anything. Actually, there's nothing to evaluate because you don't know how is this defined. Write as single integral. So take that as your question 12. Okay? Write as single integral. Question 5. Do you have your worksheet there? Can make use of, okay. Question 5. Page 1 of the worksheet. So make use of these properties to attempt those questions. If you are done with 5, if you are very fast, then look at question 6. Also, you don't need to know how the function is defined. Just apply the property. From 6, attempt question 8. 5, 6, 8, in that order.